Hello, welcome to episode 36 of live.withcode.uk. I've taken a little bit of a break over Easter, and this week we have a Martian theme because yesterday was the first time ever that something managed to fly unmanned on a different planet. So the NASA Ingenuity drone flew for the first time ever on Mars. It took off, it hovered, and then it came back down again. There's a different atmosphere on Mars. So there's different pressure, there's different gravity. So it's a real breakthrough moment for unmanned flight. So today's program, we are going to, I should probably close that. Today's program, we're going to make a weight calculator where you put in your weight on this planet. I don't actually own a set of scales, but I think I'm around about 13 stone, something like that. It calculates that in kilograms, and then it also calculates how much you weigh on Mars, and it should be able to cope with all sorts of different units. So if I put in like a punnet of strawberries, 454 grams, we need a space before the unit. It will correctly convert it to kilograms and tell you how much it would weigh on a different planet. So let's get started. We need to be able to do the conversions between the units and also the conversions to use the arithmetic operators to work out how much you weigh on a different planet. So first of all, let's display a welcome message. So Martian weight calculator. And then we'll ask a question, not necessarily how much do you weigh, it might not be a person, but please enter a weight. And then we'll tell people which units they can do. So for example, 13 ST, or you can put a unit in with kilograms or grams or even pounds. If you ask a question, it's rude not to listen to the answer, so we'll store the result as weight. And it's important that we make people put in a space between the amount, for example 13, and the unit, for example ST for stone, because then we're going to split that into two sections. We're going to have the section to the left of the space and the section to the right of the space. So weight.split with a space in there at the moment will be a list containing two items, the thing on the left and the thing on the right. We can then access those separately and process them separately. So let's see, let's call that parts because it's a list containing two separate parts. And then we can get the amount, which is equal to the part on the left, so the first item in the list, and then the unit, which is the second item in the list. But remember, list indexing starts with a 0. So 0 means the first item, 1 means the second item. Okay, so let's put some comments in. Extract data from user input. And then we need to do some unit conversions. Let's convert to kilograms. So if the user types in a unit of grams, so if unit is equal to grams, now they might type in a capital G or a lowercase g. So it would make sense if we do a case conversion on the unit, so it's always going to be in lowercase. So if they type in a lowercase g or a capital G, then the amount, if we want to convert to kilograms, needs to be the amount that they typed in divide by 1,000, because there's 1,000 grams in a kilogram. Otherwise, if they typed in the unit as stone, then I did a quick Google before this, I don't remember this, but we can convert from a kilogram to a stone by multiplying, a stone to a kilogram by multiplying by 6.35. 6.35. Otherwise, if you're American and you weigh everything in pounds, then we can still convert to kilograms, but we have to multiply by 0.454. I do remember that because I used to work on a fruit farm for a summer job, and I remember weighing all sorts of punnets of strawberries and raspberries and things like that. Okay, so at the moment, let's just check and see what we've got. We put in just one. Oh, it doesn't know what part is. I've got a list called parts, and I'm trying to use a variable called part. Let's try that. So just 1. We've got an error here because I didn't put in a unit at all. I haven't actually done validation in here. That's one of the challenges for you to work on. But let's see, 1 kilogram is 1 kilogram. 1 gram. Now we have a problem here because we've got a string and we're trying to convert it to an integer, which we can't do. So we'll have to convert this string to, well, it might not be an integer. It might be a real number, so we'll convert it to a floating point. That means it can have a decimal place. Let's try again. 1 gram is 0.01 kilograms, good. 1 stone is 6.35 kilograms, good. And what else can we do? 1 pound is 0.54 kilograms. Excellent. Now it would be nice to put some units on there. So let's use string formatting. So weight on Earth is, and then something in kilograms. What's it going to be in kilograms? Well, we'll put a value in here. That value is going to be displayed to 2 decimal places, and then we'll use string formatting to display the amount in here. So let's try 1 kilogram. That works, or 1 gram. Now that's interesting. 1 gram to 2 decimal place is 0. So if we wanted 3 decimal places, then that's what we'd need on here. I'm going to stick to 2 decimal places for now. Then we need to work out the weight on Mars. So Martian weight is equal to the amount on Earth divided by the amount of gravity that we have on Earth, 9.81, multiplied by the amount of gravity that you have on the surface of Mars, which is 3.711. Oops, 3.711. So it's about 1/3 of the gravity on the surface of Mars, because it's a smaller planet. And then we can just display that value in here. So the weight on Mars is going to be not the amount on Earth anymore, but the Martian weight. So let's see, 1 kilogram weighs around about 1/3 on Mars, but we can also do a stone or a gram or a value in pounds. Brilliant. Okay, so there's a couple of challenges to work through. Let's also display the results. Challenge 1. Make the weight display to 3 decimal places so that you can see the grams. So to do that, all you've got to do is change this value here to make it display to 3 decimal places. You can calculate the weight on the moon. So that's going to be 0.16 of the weight on Earth. So as well as calculating the the weight on Mars, you can multiply by 0.16 on here. And also you could do that validation. So at the moment, if I type in something that isn't a weight, it's going to crash. You can use exception handling or validation to try and make it so that the code doesn't crash with an invalid weight. Fab. So remember, you can get links in the description underneath this video to online interactive challenges, or all of the links are also on live.withcode.uk. Or if your school has signed up for the free weekly challenges, then you can find them on compete.withcode.uk. All right, all the best. I will see you next week. Bye-bye.